My name is José, Galizia, Tundisi. I am 83 years old. I am a retired professor at the University of São Paulo in São Carlos School of Engineering. I was a professor of environmental sciences in that university. And then after I retired, I started an institute, International Institute of Ecology in São Carlos, that is a research institute and a company, a consultancy company. I always worked in water resources, limnology of lakes, reservoirs, coastal waters also, because in my background, I did an MSc in oceanography in the University of Southampton under the direction of Professor John Raymond. And I did a PhD in São Paulo University and University of Southampton on estuarine ecology. Then I moved to São Carlos, where I started a work in the reservoir. By the way, it's 50 years now that we started this work at Lobo Broa Reservoir, which is a small reservoir that is used as a laboratory since 1971. I worked in 40 countries as a consultant, as a professor of environmental sciences, limnology, ecology. So I did my work in South America, Central America, Europe, Southeast Asia, and the African countries. So this is my background, my professional background, and I started to work in the Tietê River Basin in 1978 in a comparative work funded by Fapesp that supported the research for 50 reservoirs in São Paulo state, and among these 50 reservoirs there were these reservoirs of São Paulo state. Thank you very much for your attention. The first slide is the title of the presentation, The Conservation Management of the Nexus, Water, Energy, and Food in the Middle Tietê Reservoirs in São Paulo State, Brazil, Present and Perspectives. I would like to introduce that this talk is a contribution from the UNESCO Chair on Urban Waters, that from the University of São Paulo School of Engineering of São Carlos, and from the Brazilian Academy of Sciences, which I am a member, and the International Institute of Ecology, which I am the CEO, the president is a research and consultancy company in São Carlos. Next slide. We know that the increasing resources demand until 2050 is in the water, energy, and food, because we are increasing the human population, and in 2050 we are going to have 9 billion people in the planet, human population, and the global challenges during this period are water security, waste management, extreme events, pollution control, reduce and reuse, water cycle, and governance. And why I put urban waters? Because by 2050, about 80% of the human population will be concentrated in urban areas, in great metropolis or small towns or mid-sized towns. Next. And the urban water, of course, has an interaction with the energy, economy, environment, society, health, and food. All these components of the urban water cycle are important for the management of the urban water. Next. One of the great problems that we have in the 21st century is the increasing trend in degradation of water quality. This figure shows the degradation of the water quality from 1850, it's not 1950, this is mid-19th century, 1850, where fecal pollution and organic pollution were predominant during this period. And along more than 100 years, you can see there was an increasing degradation of the water quality, especially in industrialized countries, but also in emerging economies. And you can see that by the year 2010 and coming up to this 2021, we will have several chemical contaminants in the water, dissolved in the water, like antibiotics, pesticides, cosmetics, and therefore a very great number of different organic compounds that degrade the water quality, and they are very important for the water treatment because they increase the costs of the water treatment. Besides that, you have the variability of climate and climatic changes that changes the water quality of lakes, reservoirs, and oceans, especially due to higher temperatures. Therefore, there is also this component that has to be considered. And you can see along these 150 years approximately, from 1850 to today, there was an increasing toxicity of the surface and groundwaters, and an increasing analytical complexity because it's necessary a very high technical development, complex technical development to analyze this water quality of these water bodies. There are economic impacts due to water quality, and there are human health impacts that are not well known yet, but it has to be considered in the context of the degradation of the water quality and the overall impacts on the biodiversity, on the ecosystem, and on the human population. Next. Well, this is the Parana River Basin. You can see that there are the major urban centers within this watershed. The upper portion of the watershed that comprises the São Paulo state, especially, and other states in the north of São Paulo, was particularly harnessed by the construction of large reservoirs to produce hydroelectricity first, but they were used also for other purposes, as you can see during my presentation. Next. You see, this is the mean annual precipitation of the Paraná River Basin. You can see that the annual average precipitation in millimeters is mainly in the area of São Paulo state, and in the upper portion of the basin is about 1,500 millimeters to 1,650 millimeters. So it's a mid-size precipitation around this upper portion of the watershed, where there are located most of the reservoirs. Next. This is the mean annual temperature of the La Plata Basin, the Paraná River Basin, where you can see the temperature, the highest temperature are also in the upper portion near the Paraguay borders of Bolivia with 24, 27 centigrades. But in most of the portion of the upper portion of the watershed, you have temperatures of 22 to 24 or 20 to 22. For example, where I live in São Carlos town, the average yearly temperature is 22 centigrades. Now, this is the São Paulo state map with the reservoirs of the Tietê River, the middle Tietê River. We have 6 reservoirs, Bariri, Álvaro de Souza, Barra Bonita, Bariri, Ibitinga, Promissão, Nova Baiandaba, and Três Irmãos. All these reservoirs were built up in the last 60 years approximately. The oldest one is Barra Bonita Reservoir in the middle Tietê. That was the first one. And these 6 reservoirs were an important development for the São Paulo state, once they provided not only energy, but a series of services to the populations of all the municipalities that are around this, are proximal on the watershed of these reservoirs. But of course, they also produce the impacts that we will see in the next slides. Please. So this is the incremental increase in the area flooded in the Paraná River Basin to a total of approximately 20,000 square kilometers, 21,000 square kilometers, with the 46 hydropower plants presented here. It's important to describe that if you look at the map of São Paulo, you can see that São Paulo state has not only reservoirs in the Tietê River, but also several reservoirs in the Paranapanema River, in the Rio Grande River, and in the Paraná River. Therefore, the São Paulo state watersheds are all the rivers that are on the boundaries of São Paulo state with other states like Minas Gerais and Paraná. They are all, the rivers are all harnessed by large reservoirs. But we are talking about the reservoirs of the Tietê River. Yes, next. This is one of the reservoirs, the dams that were built up. There's a picture of the dams. I took this picture of a paper that I published in the book of the Paraná River Basin that was authored by Dr. Chris Metcalf and the 2 colleagues from Argentina and myself. That was published by Taylor and Francis last year. And my chapter was exactly on water infrastructure of the Paraná River Basin. Next, the positive and negative impacts of the reservoirs. The impact that are particularly relevant to reservoirs within the Paraná River Basin are identified with an asterisk. So the positive impacts of these reservoirs are energy production, water retention and improvements to water security, water for public supply, enhancing local and regional economy, then increasing water supply for irrigation, flood protection, introduction of aquaculture, navigation, and water supply for dry season scarcity. I would like to emphasize that besides the energy production, the positive impacts of the reservoir construction, while an important development of regional infrastructure like roads, electricity, irrigation, increasing production of agricultural goods, increase in the diversification of agricultural production. So these whole positive impacts of these reservoirs, they have enhanced the local and regional economy, and studies that were developed by Valencio and co-authors show that for 286 municipalities located in the area of impacts of the reservoirs of the Tietê River, the internal gross product in 10 years grew 80%. That was a very important growth of 8% a year due to this positive impacts. But of course, these reservoirs, they have negative impacts, which are here described on the table below. River fragmentation, reduction of water flows, inundation of settlements and human population relocation, changes in the culture of riverine human population, spread of waterborne diseases, loss of native species of high commercial value, loss of fertile arable land and valuable timber, habitat alteration for terrestrial and aquatic organisms, degradation of water quality, impaired fish migration, spawning of native fish species, loss of cultural and historical sites for indigenous populations, loss of aesthetic value, reduction of water flows downstream, loss of wetlands, introduction of exotic species. You can see there are several negative impacts that impact not only the ecological system of the river, the river ecosystem, but also change the culture and change the biodiversity. These are the main impacts of the reservoir construction. And one very important point is that the cultural changes produced by reservoirs. Studies that were done by colleagues of mine in the social area, they show that to the adaptation of the river population to a river population culture, to a reservoir population culture, takes 30 years approximately. That is, takes 30 years for the people living around the river and next the river and the watersheds of the rivers to change their perception and cultural background from the river to the reservoir culture. That's a very important point and very important impact. And the other impact, for example, like the degradation of water quality, introduction of exotic species, reduction of water flows downstream, and so on. Next. So in this table, I placed the cross-border critical issues in the Parana River Basin and some recommendations for management. I will have more detailed recommendations for management in the next slides, so I want to describe the impacts and recommendations for management now. But I will discuss here the critical issues like extreme hydrological events, floods and droughts, especially related to climatic changes that could affect the reservoirs, water quality degradation, as I showed in a slide, sedimentation of waterways and bodies of water. When the use of the watersheds increases deforestation, this produces more sediment transport to the reservoirs, diminishing the volume of the reservoirs. Alteration, loss of biodiversity, unsustainable use of fishery resources. The reservoirs change very much the biodiversity of the river. All the fishes that are dwelling and have an habitat of the rivers, they are migrating fishes, and they need a flow of water for reproduction, for food, and so on. So the reservoirs changes very much the fish community of the, and this was particularly visible in the Tietê River. Then unsustainable use of fishery resources. Well, since the reservoirs, they affect the local species, they affect the fish biodiversity, the fisheries resources in the reservoirs are impaired by the construction of these large artificial system. Unsustainable use of aquifers in critical areas also are one of the critical issues in the basin due to the construction of the reservoirs. Next slide. Continuing. There are water use conflicts and environmental impact of irrigating crops, because when you irrigate crops and you fertilize crops, you may enhance eutrophication processes. You stimulate the influx of nitrogen and phosphorus to the reservoirs, producing large-scale eutrophication. There is a lack of disaster and contingency plans for these reservoirs. Parameters for waterborne health and the deterioration of sanitation are also very, very big problems in these reservoirs. All the reservoirs everywhere in the world, they affect the human health because they can be sites for waterborne health diseases. And so, and when you discharge, for example, wastewater, non-treated wastewater in the reservoir, you increase the range and the impact of waterborne health diseases. There are navigational limitations and development of hydropower potential. That is the harnessing of the hydropower potential by the reservoirs. It's very important to say that the Tietê River reservoirs were primarily built up to harness the hydropower, and then multiple uses were added with the time into the reservoirs. But the primary goal for the construction of these reservoirs was hydropower production. Next slide. This shows, for example, what happens when the eutrophic situation occurs in the reservoirs. This is a bloom of blue-green algae, Cylindrospermopsis raciborski. Cylindrospermopsis raciborski is an invasive species. Is an African species of blue-green that is now spread all over the world due to the local, the regional changes due to global changes. So this was a sample, collected sample of a eutrophic reservoir during the climatic problems in 2015, 2014, 2015 in São Paulo state that affected very much the reservoirs of the middle Tietê. Another impact is the sediment load of the reservoir that was impacted by intensive agriculture during the Tietê River. You can see a lot of suspended material that then sediment goes to the sediment, diminishes the volume, and some of these material are aggregated to particles of this suspended material, heavy metals, for example, and this goes to the sediment, increasing the toxicity of the reservoirs sediment. Next, how we can try to manage this situation in these reservoirs. First, it's this is a picture of the design of Professor Zalewski from the Center of Eco-Hydrological Technical Developments in Lodz, in Poland. This is a UNESCO center for hydrology. And Professor Zalewski shows that if you only use engineering for management, the cost of the controlling point source pollution is very high. But if you combine engineering measures with eco-hydrology and ecosystem biotechnology, you can reduce very much the cost of the management and the control of non-point source of agriculture and the terrestrial areas that are basically impacting these reservoirs. So it's necessary not only to have an engineering approach, but also combine engineering, eco-hydrology, ecosystem biotechnology, eco-technological approaches that combined will reduce the contamination and reduce the input of non-point pollution to these reservoirs. This is an example of riparian forests that control the water quality of rivers. Riparian forests, they reduce the sediment transport, they reduce the nutrient input, especially the non-point source of nitrogen and phosphorus, so they can control very much the water quality of the tributaries of the reservoirs. Next, the same if you consider the use of wetlands. The roots of the wetlands are biofilters, and they filter nitrogen, phosphorus, heavy metals. They aggregate these substances and elements in their roots. Therefore, they are very, very effective biofilters. If you combine the forests, as you can see here, the several forests with the wetlands, you can have an effective use of the natural system, the natural ecosystem, to control the non-point source pollution. Next. Okay, what are the management strategies that we can see for these reservoirs of the Middle Tietê? First, the institutional organization to address the sustainability of the basin. The government of São Paulo State created 21 watershed committees in order to decentralize the management and the financing of the sustainability program. So the watershed approach for the administration of this management and to develop a management strategy is a very important one. The participation of all stakeholders in the committees in order to assure representation of all water users. You can have universities, industries, agricultural committees, and this civil society in order to assure very much representation of all the water users that are important to describe what are their needs and to contribute to the management strategies. There are need for technologies. This includes physical interventions such as reforestation of riparian forests, improved wastewater treatment, control of erosion and soil degradation, and of course it's necessary that each one of these committees of these watersheds develop a very important data bank for each watershed and scientific information in order to program for management strategies that are basically on sound scientific and technical information. And then knowledge dissemination to shape public perception about the ecological state of the reservoirs. Education of the population on environmental issues, and the capacity building for technical staff is also are important processes for the management strategies. Next is and financing. To financing the local or regional support, to provide financing for local or regional support for implementing management and recovery initiatives. For example, again, the São Paulo state created, based on the Brazilian water law, created funds from the penalties assessed for pollution and deforestation. Then these funding sources, including taxes and payments for environmental services, and for example, all these watersheds, they receive funds from this pollution and from penalties from pollution and this deforestation, and this can be applied in research and management of these reservoirs. But it's very important to finance the technical activities, the social activities. It's very important to emphasize that the management cannot be only on the technical issues. It has to include the social problems, the economic problems, the water quality, the quality of life of the population, the human health, in order to have a clear management and a very advanced management initiative for the 6 reservoirs. Next, the basic information for the management has to include the information system, a data bank, planning, management, and sustainable handling of water resources, issues of environmental protection and rehabilitation, education, communication, public participation, research and technical development, and institutional strengthening. This is a summary of the management strategies I have described in the slides that were just shown. But it's very important to have a data bank, very important to have technical approaches, but at the same time, financing, education, communication, public participation, and long-time planning of the management strategies. Now, some details of Basin water quality standards. First, standard for irrigation of water quality standard for irrigation, water quality for drinking waters, water quality for river water, and sewage effluent water quality. Next, develop basin water quality regulation plans, agrochemical regulations. You see, you have to make an effort to develop regulations for the use, for example, of pesticides, herbicides, and nutrients for the vegetation in order to protect the water quality. And then it's very important to do also to control the total maximum water withdrawals, not only for the energy production, but to combine the energy production with the multiple uses. The reservoirs were built up to produce hydropower, but then several other uses were placed on these reservoirs. Therefore, to manage the water quality and to manage the reservoir, you have to adjust the different water, optimize the different water management and the management of the reservoirs. You have to adjust the power production with the fisheries, with the navigation, and so on. You have to regulations for the groundwater extraction, mining regulations, daily waste reuse and management plan, and river environment management plan for the whole river system, or for the 6 reservoirs of the Tietê River. Next, and finally, develop basin infrastructure plans, the river basin management plan, the regional sewage development plan. Not all the municipalities of the watersheds that belong to the reservoirs of the middle Tietê River, they have sewage treatment. You have to treat the sewage of all the cities that belong to the watersheds that are in which are the reservoirs of the middle Tietê. Therefore, you have to develop a very strong incentive for the municipalities to treat the sewage. The same for the land use and zoning plan. Protection and conservation and recovery of gallery forests, vegetation mosaics, wetlands in the watershed. Wetlands are very important. Wetlands, they not only reduce the non-point pollution, but they treat, for example, they lose nitrogen for the atmosphere because they reduce nitrate to nitrite to ammonia to nitrogen that goes to the atmosphere. So besides protecting gallery forests, vegetation mosaics is very important to protect also the wetlands. And the water resources management plan that are basically are integrating the infrastructure plans for the basin. Next, I am here in São Carlos. Next, yes, these are the watershed of the municipality of São Carlos. In the urban waters system, we have to develop a vision of the urban watersheds that are very important because you can start to control and manage the watersheds by managing the urban watersheds, maintaining repairing forests along the urban watersheds, treating sewage. By the way, São Carlos treats 100% of the wastewater. That is very important because this water goes to the Tietê River through several different tributaries. Next slide, and final slide. I would like to discuss a little bit this point because this is very important. There is a connection and an interaction between the natural resources that are water, land ecosystems, biodiversity, marine resources, non-renewable resources. And of course, these natural resources, they are subject to, and they can be subject to environmental vulnerability. The human security depends on these natural resources: water, food, energy, health, income, livelihood. Of course, there is a relationship, very important relationship between natural resources and human security. At the same time, we have the climate system. The natural resources, they depend on the climate system. The sustainability of the natural resources are depending on the climate system. That is temperature, precipitation, extreme weather, ice cover, ocean currents, and sea level. And the social stability depends very much of the interaction of these three components: natural resources, human security, and climate system. Political events, migration, violence, conflict, cooperation, institutions, these are very important issues for societal stability. Therefore, if you have any vulnerability or instability in each one of these three components, natural resources, human security, and climate system, you may have conflict sensitivity of the social stability. So the resilience of the social stability depends very much on the functioning of these three systems. The global changes that, of course, will change temperature, precipitation, produce extreme weather, and so on, can change natural resources, can change the availability of natural resources, which can change then the human security. And this could produce societal stability. For example, water security, it's very important for societal stability. Food security is very important for societal stability. Energy security is extremely important for societal stability. So the nexus between water, energy, and food production in the Tietê River Basin will depend on the maintenance of this system. Therefore, the management capability and the interaction of the technical and the scientific development with the economic and social system is fundamental to maintain the social stability in this region and making further good use of the water resources of this river. Thank you very much.